Here is a question P215 on projectile motion under the topic mechanics. A particle is projected upwards in a direction inclined at 60 degrees to the horizontal. Show that its speed, when it is at its greatest height, is half its initial speed. Okay, let's see how we answer this question. So a projectile is any object that is moving freely under the force of gravity. When we throw an object upwards, it will be moving only under the force of gravity if we assume that there is no air resistance. Okay, so if we project a ball or a stone vertically upwards or horizontally or at an angle, that object will be moving freely under the influence of the force of gravity. In that case, we will refer to the motion of the object as that of a projectile. Okay, now again, we will assume that the object is moving under zero air resistance. Okay, if we project the object at an angle, at some angle to the horizontal, then the object will be moving in two directions at the same time. So here is an example. All right, so here is an object which has been projected at an angle of theta to the horizontal and with a velocity u. Okay, so the velocity of projection there is u. Some people will refer to this as v at an angle of theta. Such an object moves in two directions at the same time. Okay, one of the direction is horizontally and the other one is vertically. So that's why it rises, but also that's the reason why eventually it will have covered some distance in the horizontal direction. Okay, the distance, the maximum distance covered in the horizontal direction is referred to as the range of the projectile. Okay, the projectile also reaches a certain maximum height before it goes back down. All right, so what we need to remember is that as it moves horizontally like this, it is moving both vertically as well as horizontally. Now, if there is no air resistance, then the velocity in the horizontal direction remains constant because there is no horizontal force either to slow it down or to speed it up. Okay, so the horizontal component of this velocity is going to remain the same throughout. Okay, the vertical component of the velocity, that is upward movement, the vertical component will be reducing because in the vertical direction there is force of gravity which will be slowing it down as it goes up and speeding it up as it comes back down on the other side. So this object is moving in two directions at the same time. So as it goes up, the vertical velocity reduces. So when it reaches the maximum height, the upward velocity becomes zero, and that's why the object no longer goes higher. Now it will start coming down, which is to say that its velocity will have changed direction and will now be downwards. And that velocity then starts increasing as the object is going down, like that. So that's vertical velocity. Vertical velocity increases on its way up and reduces on its way down. Horizontal velocity remains constant as the object is moving, all right? Does not change because there is no force to slow it down or to speed it up. So I'm going to show this using velocity vectors like this. Okay, so at the start of projection, it has a horizontal component of this velocity, u. The horizontal component is given by u multiplied by the cosine of the angle, in this case cosine of 60. The vertical component is given by u sine of 60. Okay, so as it moves up, what happens? Let's see what happens to the vertical component. That's what happens to this yellow orange arrow. So as it's going up, the orange arrow becomes smaller to indicate that the velocity is becoming less and less on its way up. The velocity is becoming less. It's still there, but it's very small, as you can see there. All right, and when it reaches maximum height, its vertical velocity is completely gone. Right, and if we continue moving, now the object is going down, and so the vertical component of the velocity is now downwards and continues to increase like that. Okay. So this is how we reason. On the other hand, if you look at the horizontal velocity, it remains the same. So the length of the green arrow stays the same as the object is moving forward like that. This is important if we're going to understand projectile motion. All right? Now, keeping that in mind, when the object is at any point, let's pick a point such as this. Right? So when the object is there, we can find the speed. The speed refers to, the speed in the direction of motion. So the object is moving like that. It's not just going up or that. The effect of the vertical component and the horizontal component, if we use Pythagoras theorem, first of all, Parallelogram Law of Forces, if we were going to look for the component, for the resultant of these two, we need to draw a vertical line like that and a horizontal line, and then from that object we draw a diagonal like that. All right, so if this is the vertical component, let's call that uy, and this is the horizontal component, let's call it ux, then the speed of the object, which I will refer to as u with a modular sign there like that, I don't have to put that really. So the speed at this time is going to be given by the square root. So u modulus is going to be given by the square root of ux squared plus uy squared according to Pythagoras theorem of this triangle here. Okay, so basically that's how we find the speed of the object. Okay, so the speed refers to when we refer to the actual direction of movement of the object at the instant when it is at that point. Okay, so this is how we would find the speed. However, when the object reaches the maximum height, there is no vertical component of the velocity, so all the velocity is made up of the horizontal movement, which means the speed is also based purely on the green arrow. So let's see what happens in this case. So we've said that the horizontal component of the velocity at any time. So at the beginning here, we can find the horizontal component of the velocity somewhere there. This horizontal component is the u, this velocity of projection, multiplied by the cosine of the angle there, angle theta. In our case, that is 60 degrees. Angle is 60 degrees. The vertical component of the velocity is here, like that. All right? And so the component here is u multiplied by sine of 60 degrees in our case. Okay? All right. When the object reaches maximum height, when this object reaches its maximum height there, then we no longer have that vertical component. So therefore, its velocity is purely made up of the horizontal component. We can say that the speed of the particle, in this case, the speed, let's call it u, is purely going to be this component of the velocity. Square root of the same thing is just the same thing, and this is going to be u multiplied by cos of the angle, cosine of the angle. We say this remains constant, u cosine of theta at maximum height. This is u multiplied by cosine of 60. Cosine of 60 is a half, and so this is 1 over 2 u. So we have shown that at the maximum height of projection, the speed of the particle is going to be a half of the speed with which you projected it. Okay, I hope this is clear. If it is not very clear, let me know and we can go through this again. I'll try a different approach. Okay, thank you.